Morning, folks. How you guys doing today? All right. Give that little pause here. Welcome to week 5. We are cruising along. All right. Someone has done an in real life word ban. Oh dear. On that word? Scholar? All right. I will give it a try. All right, so we have a couple things on tap today. First, we're going to go over my solution to Project 1. Again, it's just the way I would go about it here. I find these tend to be relatively worthwhile just to see a different approach to how you might have solved the problem. And, just because yours doesn't look the same does not mean it's wrong. Don't worry, right? If it works, then yours is fine. Right? There are lots of different ways to solve problems, and that's okay. Everyone's going to do it differently. Now, some might be more efficient than others. Sure, that's something. You'll learn more about that when you take the data structures class. If you guys continue on 2353, we'll talk more about efficiency, those sorts of things there. But yeah, that could make it better. But other than that, really like one approach versus another, just whatever makes the most sense is okay. So I'm going to start up a new project here. Let's do in the right folder, 2151. This is project 1. Oh, nice. Yeah. You enjoying data structures? This is the morning version. I already did this one for the Thursday night class, but I'll build another one for you guys. All right, let's see what we got. Sweet, first project. Yeah, I've got a chance. I think I'll be teaching that one over the summer if all goes well with our scheduling. I taught it a couple of years ago as an adjunct and had a lot of fun with that one. That's a really good class. I'm a big nerd, so I like data structures and stuff, but it's a really interesting stuff for sure. So again, we didn't actually need a main. We're not going to do anything with the main method here. We're just writing a class and we're testing the class. So the idea here is that I don't have to make instances of my class and call the methods and see if they do the right thing in main using a bunch of prints or in debug mode even. Right? I want to make the computer do this. That's why we like unit tests. So I'm going to go add a new class and we'll call this one plain. And let's take a peek. Let me go back here and make sure I don't miss anything. So let's take a look at the plain assignment and make sure we get all the nice details here. All right, 23 people submitted. Thought we had more people than that in class. I'll have to take a peek and see. Yeah, we can chat about it after, software. Did you send me an email earlier? I think you did. Yeah, we'll take a look and find your repository. All right, so we're going to write the plain autopilot. We're going to have some private attributes. We're going to have get methods for each attribute. We're going to have a constructor. We're going to have enable and disable landing gear. I had thought doing them separately might be easier. A couple people combined them. That's okay too, like a toggle landing gear where it just did the right thing based on its feet. So sure, that's fine, as long as it's doing the correct function here, and then change altitude. And then unit tests for all of those. So what I'm going to do is I'm going to write stubs here. Okay, right? The stub is not going to be the official final code. It's just going to be a placeholder. So it's a little bit tricky to do some of those stubs without attributes. So I'm going to write the attributes. We're just not going to do the right things with them yet. Okay, so we'll have private. This is going to be like an max altitude in feet, and then we're going to have a boolean, private boolean, landing gear enabled. Model was going to be a string model. Oh, there's the semicolon. And then another int for current altitude in feet. Okay, oh, posture check, thank you. I got my little backboard here. I slept terribly last night. My little guy is not feeling so well. So he's in the bed all night long, kicking me and being stuffy. There. All right. Oh, ouch. If I sit up too high, I hit my head on this. Forgot. All right, so we got a couple of those. And then we'll have a constructor, right, that accepts some values. Sure. So we'll write our constructor. Again, we're just doing stubs here. We're not going to do the official final everything yet. So I'm going to write the constructor needs to be available to everyone to use, so it's not private. Okay. And then the constructor's name matches the name of the class. And then we're going to take an int for a string for model and an int for max altitude in feet. Altitude in feet. Oops. And I'm just going to leave a note to do finish me, please, because we're just writing stubs. We're not actually going to finish any of the code yet because I want to get the methods available so I can put them into tests. Right? And then we need get values for all of these. So sure, I'm just going to insert code. I want getters for all my attributes. Now, these ones are actually going to work, but that's okay. I don't feel too bad about that because we don't have a way to change them yet. So they're just going to give some defaults. Okay. Remember, defaults for ints are 0. I believe a Boolean defaults to off, and then a string is going to be null because that's a reference type. So if you don't assign values, bad stuff happens. That's why the constructor's job is to assign values to all those things. Okay. And then did you want to do a single method for enable landing gear and disable landing gear? I like having them separate, so I'm going to do them separate here, unless you guys want them separately. And again, I'm going to use this Boolean status to indicate whether or not it worked. I'm going to have enable landing gear, and because it's a Boolean type, I have to return something in my stub. So again, to do fix me, I'm just going to return false, because I just have to pick one. And then a Boolean disable landing gear. Do fix me. And again, we'll just return false, because we don't know what that's supposed to do yet. And then I was going to do the same thing with a Boolean for change altitude. Altitude. And this takes an int, I don't know, change in feet or something. And again, I'm just going to return false, because I don't know yet. We haven't finished it with the to-do to fix me. So what I have here is just a bunch of method stubs. The methods exist. They're not exactly doing the right thing yet. The gets, but we're not actually setting any values, so we don't expect them to behave properly. But now that I have methods here, right, I have the shape or the form of my class, the things I need to do, right, we've got all the pieces ready to go, just not finished. Now we can write unit tests. We can do this test-driven development. And then our job can be to make the failing tests pass. And you didn't have to go about it this way. That's okay. There was no points for using test-driven development. It's just, I think it's a really good practice for making sure that we focus on getting the right stuff done here. Because if you know what your class looks like, if you know the design, you know all the private attributes that it's hiding, and you know all those non-private attributes that you can get at through these types here. Someone did an in real-life word ban. I should put like a timer on that, right? I don't know if I can go all morning without saying that word. So we know what it should look like. We know how to interact with it. We should be able to write the tests because we know what its behavior should be before we even code the behavior. This word right here, grow. The not private. Thanks, sweetie. All right, so I'm going to right-click on plane. I'm going to say navigate, go to test. Right, and make sure you use JUnit 4. The new version, I got tired of fighting with it. So it just works. Right, JUnit 4, say we don't need any of these generated code things. Sometimes they're helpful, sometimes they're not, so I'm not going to bother. So we're just going to say OK. And it should give us a new test package. Ready to go. All right, so plane test, and then here we go. Get max altitude in feet, landing gear enabled, get model, get current altitude in feet. So all these gets were actually... So we're going to do all of that in the constructor one time. That's really weird, Gatton. Have you upgraded NetBeans lately, maybe? Or, I mean, it's not new, so I don't know why it wouldn't have it. We can spend some Google time later and see what's going on with it. it just was there. So when I was at my plane class, I went navigate, go to test. Oh, I already have them here. Hang on. We can recreate them. No big deal. Let's delete that. Delete. All right, one more time. You right-click in your class. You go to navigate, go to test, and it should come up. Hey, let's make some. Create or update. The framework drop-down. Someone else was having that problem too, and I feel like they had to upgrade. And IntelliJ is good too. We're using NetBeans because that's the one we use. We also use it for the PHP and JSP web development course. So makes life easy. Just use the same IDE for everything. All right, so one more time I'm going to generate it. If you don't have it as an option, we can talk after. Did the other tests work for you then, or you just didn't test anything for project 1 and didn't tell me? I'm a little confused about that, but we can chat after. All right, so again, all these gets, we're going to test all of those in the constructor when we create the constructor, when we test that. So I'm going to get rid of those ones here, and I'm going to just change this one to test constructor and gets. I don't know. It's not ideal, but that's okay. Okay. So what we need to do then to test if that works, right? We're going to arrange, we're going to act, and we're going to assert. So the things that we need, we're going to have expected values, right? So I'm going to have a string for expected model. We'll say ours is what, 747. We'll have an int for expected max altitude. I don't know, let's just pick a really big number, like 50,000 maybe. It doesn't really matter here, but and I'll have an int for expected actual altitude. Probably 0, like when we make a plane, it probably sits on the ground. And I know that's not proper because altitude is really like above sea level. So here in Michigan, we're above sea level, so the altitude wouldn't be 0. But again, this is not all that complicated. We're just pretending here. And then a Boolean for expected landing gear status. I'm thinking it should probably be true to start because we're sitting on the ground, not flying. Oops, true. There we go. All right, so those are all ready to go. All right, so that's the things I expect. Then we're going to act. We're going to actually create a plane. So plane equals a new plane, and we're going to hand it the expected model and the expected max altitude. Expected max out. Nope. Max altitude. There we go. And then we're going to get all the actuals, right? So we're going to call the code that we're testing, and we're going to get the actual values back out. Let's ask the code what it thinks its values are. So the string for actual model is my plane.getModel. We'll have an int for actual max altitude, plane.get actual, or get max altitude. There we go. A int for actual altitude, expected actual altitude. That should be current. Expected current altitude. There we go. Current altitude. Okay. I'm using the wrong words here. Plane dot get current altitude in feet. There we go. And a Boolean for actual landing gear status. Plane dot get. So this one, notice, is landing gear enabled. So when we auto-generate setters and getters, a Boolean for us gives us is, because it's true or false. Right, so it just changed the name from get to is because it's a Boolean. So either way is perfectly fine. I don't care how you name it. That's just what it does with the auto-generation code. So you could put it in here, but then when we go to our asserts, you'd have to type it again. And anytime you have a string or like an integer in your code more than once and you're not using a variable name, you should feel bad about yourself, Dre. So it makes it cleaner handing it to the constructor and then using it again, the variable in the asserts. because otherwise we have to have the exact same string literal or 50,000 value in there more than one time, and that's not cool, right? That's embarrassing. And then we're going to assert. Well, assert equals. Okay, the expected model and the actual model. Look at that, it guessed it for us. That's amazing. Assert equals the actual, the expected max altitude and the actual max altitude. Well, assert equals the expected current altitude and the actual current altitude. This last one here, this one's actually a little bit silly because I don't want to say assert equals true when I can just say assert true. So assert true is a little bit easier here than having to say, does a true equal a true? Right, so it just skips a step and then there's one less line of typing here. We just say, hey, it should be this. Does that make sense? So I skipped that one. I can take that one out. All right, so we got one test. Look at that. We got our constructor. And if we run it here, it's not going to work, but that's okay. So again, usually a unit test should test one method. Sometimes you have to do more than one, especially when it comes to gets and things. But ideally, you want to have a single unit tested at a time. So like this, we're testing the constructor method. So again, with the constructor, we're also getting all of the get methods here because that's the only way we have to actually check those values. So we do a little bit of combining, but again, the gets don't really count because a really boring get method just returns the value. So we don't necessarily want to do those separate. But things like our enable landing gear, disable landing gear, we definitely want to test. Change altitude, we're definitely testing. We're trying to have one test per case for this. Remember, because we're going to have different cases for what's actually going to happen here. So enable landing gear that works and enable landing gear that doesn't work. So we're going to have two different tests, right? Because the idea, our requirement here, are just going to say if our altitude is above 1,000, we can't turn it on. So in here, we just called the constructor. We gave it a model and a max altitude, and then it should also set defaults for the other things, the landing gear status and the current altitude. And we're going to assert we got those default statuses. So I pass it the two things, the expected altitude and the model, and it should default itself to some current altitude, whatever it happens to be. We could find Michigan sea level if we wanted. Right, sea level in Michigan. Or that's not the right thing. No, like altitude in Michigan. Ground altitude in Michigan. I don't know. There's some term I'm missing here. Elevation? That's what I want. Elevation. Michigan. Okay, between 500 and 1,000 feet above sea level. So our altitude between 500 and 1,000. There we go. That's the right. You gotta Google the right thing. There's actually a really funny shirt here. There's a really funny shirt. This is totally worth it, by the way. Let me find this here. Let's see. It's a really funny shirt. I bet we can find it. No. I'm sure we can find it. Oh, man, I've seen it. Let me see. Aha, I think this one's it. Yes. Yes. This is totally worth it. Come on, load shirt. It's got to be it. I'm going to be disappointed if it's wrong. Here we go. What I say, I'm a software developer. ... Well, people hear, I can repair a computer, fix your internet, configure your printer, revive your phone, set up your email, hack into any system, all for free. But I mean, I search up solutions better than the average bear. Oh, like Googling, searching stuff online is legitimately a serious skill in software development, software engineering. You have to be able to learn to find good information and find things. Like, I mean that 100%. Like, nobody has it all memorized. Nobody. And it's not worth trying to memorize all of it. You get familiar with the tools, you learn what is possible, and then when you need to do it, you go look up how. Right? So the whole reason, all that we're doing, the things that we're learning in classes, is to expand your toolkit and expand your knowledge and say, okay, here are things that can be done. You don't have to memorize them. Right? That's stupid. Right? I mean, sure, sometimes in academia you have to memorize crap, which is terrible, and hopefully we're working on changing that, because we realize that's a terrible measure of things. But you just need to know you can do this. You have this tool in your toolkit. Let's go look up how to use the tool later. Right? That's what it was. So, sure. Okay, so expected current altitude. Let's say 600. This is Michigan. Right? Why not? Why not? And our test failed. Right? Expected 747 was null. Right? So we got a big fail here, because if you don't initialize a reference type, you get nulls, which is bad. But that's okay. Right? We're just setting up our tests here. So again, we expect it to be 600. We'll put in a note later. We'll fix that after. So that's that one. Okay, my test enable landing gear. So I guess some of those values where like your height is between 0 and 1,000 is probably wrong, because we didn't have an offset for like normal ground level. But again, that's fine. This is okay. So enable landing gear. Right, what we expect to have happen. Assert. Act. And nope. Arrange. Act and assert. Yeah, I don't know why I did assert first. So to enable landing gear, if we're 1,000 feet or below, it should work. Right? So this is, we'll call this one works. So it should just work, right? So if we just make a plane, plane equals new plane. Now in here, I'm not testing the model or the max altitude, so I'm just going to put in some garbage values because I don't really care. Right? This, because I'm not going to use them again. Before, because I was using the model again in my asserts, I definitely wanted it as a variable. Okay? And then we'll have an enable landing gear status. So this will be a Boolean enable landing gear, or I don't know, actual enable landing gear. Plane.enable landing gear. Now, it's already enabled, so I don't really care, but that's fine. So we should assert true. True. That the method told me yes, it worked. And then I also, it's probably worth checking, Boolean actual landing gear status. Right? The method should return true, and it should actually be on. Right? We kind of want to test both those things. Right? Make sure that it still stayed on even though it told me true. Because it's possible to screw that up. Right? Okay, so I got that one where it works. And then I disable landing gear. Oh, no, I'm sorry. So we need one where it doesn't work now. Does not work. So it's not going to work if the plane goes up too high. So we're going to take our plane and we're going to change altitude. And let's go up, say, 20,000 feet. I don't know, 2,000 feet. Sure, why not? Some value that puts me above that threshold that we said was 1,000 that it should not enable. And then we'll check if our landing gear is enabled. So actually, I'm going to feel a little bit bad here, but that's okay. We're going to disable the landing gear. So I don't care if that works or not. I just want to know that, because I want to make sure that it's off, so that when I do try and enable it, it doesn't enable, and I want to know that it stays off, actually stays off. Because nothing in our code says we can't keep going higher and higher and higher with the landing gear on. I think we kind of screwed that up a little bit. And again, that happens, right? It's hard to be very specific with all those details here. So it should be false, right? Assert false, that the actual landing gear, enable landing gear returned. It should tell me, no, you can't do that. And then when I ask for, hey, what's the status? It should also return false. Like, hey, no, our landing gear's off. You tried to turn it on, I told you no, and it is actually off. Right? I want to make sure that it doesn't turn on. Right? So I'm turning it off first to to make sure that it stays in that off status, to make sure that turning it on didn't actually change it. And that's all. All right, so we'll try those. All right, landing gear does not work. Ooh, bummer. So this one's passing, right? And we don't have any working code, right? Because remember our enable landing gear, what we did is we said return false. Just all the time return false. And the get landing gear status is returning the default value, which is false, because we haven't set it in the constructor yet. So that's a little bit suspicious, right? You should feel suspicious of any test that passes before you write any code. Now again, it's a little bit tricky at this point for us to fix that. So know that it's suspicious, but really there's nothing we can't really do anything about that right now, because trying to change that would be obnoxious. Okay? All right, we okay with that? I mean, why this one is passing right now? We feel bad, but it's okay. All right, now we're going to do our disable landing gear. We have a works and a not works. So the disable landing gear, we're going to do pretty much the same thing, but this time we need to go up high. Right, so if we change our altitude and then we disable the landing gear, it should work. The Boolean actual disable landing gear. And see what happens. And then the status should be off. And we're making a plane, we're flying it above that 1,000-foot mark, because we know that's what was in our code, that we had to get above before we could turn off the landing gear as a safety feature, right? Make sure you don't turn it off if you're too low to the ground, and we'll make sure that works. So, oops, I'm sorry, these should be assert true that it actually did disable, and then false that the landing gear is disabled, right? Enabled false, it's not turned on. We'll run this one. All right, and disable landing gear works, fails. That's what we expected. Okay, and then one more for disable landing gear does not work. Right, so if we don't change and we try and disable the landing gear, we should get back a false. And then the landing gear should actually stay on. Right, because we haven't moved off the ground. Right, so we're just setting up all those different cases that we know we're going to have in our code to make sure we get 100% code coverage. All right, disable landing gear works and does not work, fail. They both fail properly. That's good. That's good. All right, and then change altitude. Now, change altitude was a little bit tricky, right? We had a couple different things happening here. We don't allow the plane to go above max altitude. We don't allow it to go below 1,000 if the landing gear is not enabled. Right? And again, I'm using that Boolean status. So like if you tell it to do something and it worked, you get back true. If something happened and I had to fix it for you, I'm giving you back a false, because we haven't talked about exceptions yet. And I'm still feeling bad about that. You guys with me so far? So we're going to do change altitude. So this is going up. Works. All right, so we're going to need a plane. Let's just copy one of these, I guess. We'll just write some more. We'll do it ourselves. We'll arrange, we'll act, and we'll assert. Okay, so I'm probably actually going to need to know that our current altitude starts at 600. Right, and I'm going to need that in lots of places. Right, we've got a couple options. If I'm going to use it more than one time in plane test, right, might as well keep it here. So let's write a private int starting altitude or something. Sure, starting altitude is 600. Here we go. And we'll just set that to the starting altitude here. Right, this is a class. You can add values to the class here. Right, now I can use this other places throughout all my test methods here. Okay, because we're going to, anytime we change our altitude, we're going to have to factor in that we started at 600, right, and then went up or down from there. Okay, so range, we're going to have to make sure that altitude works, we're going to have an int for expected altitude. Altitude. So if we go up, say 1,000 feet, right, let's say 1,600. Right, we could do that. Or we could do our arithmetic. Maybe it's easier with some arithmetic. So our int for change in altitude. Altitude is 1,000. And then our expected altitude is going to be our change in altitude plus the starting altitude. Right? Why not? In case that changes, this will make life easier for me later on. Okay, and then we'll make a plane. Plane equals a new plane. Again, we don't care about the model, and we do need a large max. So we need the max to be bigger than my change, right, for this test. Okay, then we're going to have a Boolean result for, I don't know, actual change. Change altitude, or change altitude result or something. I don't know. Sure. Plane dot change altitude. And we want to change by the change in altitude. And then we'll have an int for actual current altitude. Is my plane dot get current altitude. Okay, then we can assert. So right, we're going to assert true that the actual change altitude worked. Right, we got back to true, and then we'll assert equals my expected altitude matches the actual current altitude. So if it works, right, we went up 1,000 feet. We should be at 1,000 plus the starting altitude, 1,600. Actual current altitude. Okay, I think I had the wrong variable name there. Let's try that. So this one should fail. It's all good so far. Okay, great. So that one fails. We're feeling good. Okay. Going above max does not work. So if we go above our max here, then it shouldn't work. So if we set our max, I don't know, int, we'll have a max altitude. Altitude, say, is, I don't know, like 5,000. Then our expected altitude should be the max, right? Because we're going to stop at the max. So if we say the plane's max altitude is max, and we change altitude, we try and go up the max. If we already start at 600 and we go up max feet, right, we should stop at max because we've already added more to it. So that should be false. We should assert false. But then our actual current altitude should be the max, right, whatever that max is. So our expected should be the max. We go up the max. We stop at that ceiling, right, the max altitude. We should be good. Let's try that one. Okay, that one's good so far. So let's try this one here. Let me copy this one. So it's going up, going up. Now we're going to test the going downs. So going down works. So again, this one's a little bit tricky because we have to go up and then we have to go down and make sure that when we go down, we give it a true result. Right? So if we change, I don't know, we need to go up a bunch. I don't know, let's just go up like 100 feet. Okay, let's do this one. Okay, so let's get rid of the change. We'll make change in altitude 100 here, and the expected altitude then will just be the starting altitude. So we'll go up 100, we'll go down 100. Make sure it works. So we'll go up 100, and then go down 100. So I'll take negative change in altitude. So we're first going to go up. You know what? Why not? Let's forget that. So we'll just go down. So negative 100 is our change in altitude, and it should be our starting altitude. Now, because this is negative, I'm going to add it, right? Because if we subtract a negative, we're going to increase, and you don't want that. Right? So if we start at 600, we should be able to go down 100. Just pretend it works, okay? Like, sure. We didn't put any rules in that say we can't get below at 0 altitude. Because, again, we don't really know what our altitude or the ground level is here. We're not that smart. We probably should do something with GPS and maps and all that sort of stuff. But, again, you know, we're not there. We're just making the plane class. So it should work to go down 100 feet. We should get back to true. Okay? And our current altitude should be 500. Let's see if that one runs and fails. Right, it doesn't work. Now the last one here is tricky, right? We shouldn't be able to go below 1,000 without the landing gear. So to get to that, we have to go above 1,000, we have to turn off the landing gear, then we have to go down. So the test, we're testing more than one piece here, and we feel a little bit bad about that, but that's okay, right? We want to make sure that that functionality works to get 100% code coverage. Going down, stops at 1,000 without landing gear. Right? Make sure that that works. All right. So we're going to get rid of this change here. Our expected altitude should be 1,000, because that's where we're going to stop. Right, so we make a plane. We need to go up a bunch. So I don't know, let's just go up 1,000. Oh, sure, let's go. We'll go up 1,000. Change altitude. If we go up 1,000, and then we turn off the landing gear, disable landing gear, and then we try and go down 1,000. It should stop us. Right, so that we should get back to false. Something wrong happened, and then our current altitude should be stuck at 1,000 because our landing gear was off. And our plane autopilot says, nope, you can't go below 1,000 without your landing gear. So that, again, a little bit tricky. A lot of things going on here. We have to use a bunch of methods. We feel a little bit bad about that. But again, we want to make sure that change altitude stops us at 1,000. So that's the ultimate thing that we're testing here. So it's not going to work till these other things work. And that's okay, right? That's all right, because it does depend on this other functionality. We're okay with that. So I think so far, then, with all these tests that we have, we've tested everything that we know plane should do. Right? We look at our definition. We know what it's supposed to do. Now we have tests for all of that. So that's the idea. That's test-driven development, is we know what the design and functionality is. Excuse me. Right? We know what classes we have. We know what the classes are supposed to do. We know how they interact with each other, with their private methods and their not private methods. Right? Thanks for that word band. And we can write tests, because this is the behavior I expect to get. If you don't know what your class is supposed to do enough that you can write tests, you have no business writing code anyway. Right? If you don't understand what the class is supposed to do and how it behaves when you call these methods, how do you expect to write some code? Yeah, I'll post it all on GitHub for sure. Okay? So this is really good, and it focuses us, make sure that we know, hey, this is how it's supposed to behave. It's fantastic. Now we can actually go write some code. Right? Let's go make this thing work. So let's do the constructor first. We'll take my this model equals the model, and my this.max altitude equals the max altitude, and my this.current altitude. Now this one here I'm going to feel a little funny about. We might want some sort of value. Right? We said 600, so we could make it like a static value because it's defined once, and set each plane's current to that static value. We could do that. Right? So we could have we could make it public, we can make it private. I'm not too particular one way or the other. If it was public, then we'd be able to get at that value other places, like in plain test, which might be nice. Let's try that. Oh, I'm sorry, not private. I keep saying the word. Int. So this is public static final int. This is starting altitude in Michigan. 600. Great. So now I can actually go fix up plain test here. We can get rid of all this nonsense. And I'm going to feel a lot better about it. Nothing wrong with it there, but if we have a public value, come on, we can go get it over here. So it's plain dot. Oh, come on. It wasn't compiling here, so it was upsetting my test. Plain dot. Here we go. Starting altitude Michigan. You have that anywhere else? Plain dot starting altitude in Michigan. Right, so I can use that static value other places here. Right, other code that references plane. Starting altitude in Michigan. Why is it doing that? Okay. Cool. So I think I got all those changed. I'm feeling good about that. I like that. So our current starts at our starting altitude in Michigan, and then my landing gear enabled is true. We're going to assume landing gear's on. Hydration. Thanks, Snake. Get your coffee, folks. You guys are really missing out. I feel bad for you. Not meeting in person. I don't have my coffee pot to share with you. I used to just bring the coffee pot and I'd brew coffee right in the room just to make it easy. That was before I had an office. So I think actually I'll have an office near an F building. Oh, that'd be cool. So I can make coffee in my office. Of course I share with students. You think I'm going to drink coffee in front of you and not let you have any? Like, how cruel is that? Like, hey everybody, I'm drinking nice hot coffee I just made. You can't have any. It's especially important at the night classes. I used to mostly teach night classes. So like, yeah, if you're there from 6 to 10 at night, you need the coffee. You did a hat? Oh my goodness. Where are all my hats? Sweet tea, I missed it. I'm sorry. Here we go. Here we go. I know, I'm sorry folks. This pandemic is crap, but hopefully we're all keeping safer for it and keeping our grandmas safer. So there. Will this do? Here, I'm like it's Sith Lord coding time, right? We should turn off the light. Make it a little darker in here. Get that dark mode. Oh, turning off my lamp doesn't do anything, but oh, it did a little bit. It did. I'm just delayed. Here we go. I'll leave that back off. All right. There we go. All right. So we got our constructor. Yeah, what was that? What was that show? Hacker One or something, or Mr. Robot, right? Mr. Robot. I could pull this off, right? I could get this look. Oh, he does not have a beard. Does not, so I'd have to shave. Lose a little bit of weight. Yeah, I don't know if I can pull that off. Okay, sure. I heard that was a decent show. I've been meaning to go watch that. Anyway, so we wrote a constructor, right? We did one thing. Let's go try our tests. Uh-oh. Our constructor and gets didn't work. Was null. Did we do something wrong? Lane. You know what? I think I have to change that stupid setting. Compiling on save. That ought to do it here. Now let's try our tests. Did that do it? There we go. I think it's going to do it. Now it's building the project, of course. There we go. I should get some blackout curtains for that window back there. That might be nicer. Could actually like really darken up my office. This was the kids' playroom until we moved things around. All right, our constructor passes, right? So our job, once we have our tests done, is to start making these things turn green. That's our focus, okay? All right, enable landing gear. Let's do that one first. It's next in line. We're going to say if current altitude is less than or equal to 1,000, right? That was our enable landing gear. If it's greater than 1,000, don't enable. Okay? So if it is, we'll take our landing gear enabled, equals true, and return true. Otherwise, we return false. Right? Again, it's redundant to have this inside an else, because if you hit a return, your code stops. Right? So there's no point in having it in an else. It doesn't hurt to be in an else. There's nothing wrong with it, but it's just redundant. And why write one extra line of code if we don't need to? Right? Disable landing gear. If our current altitude is greater than or equal to 1,000, we'll take our landing gear enabled, it's false, and return true. It worked. Otherwise, nope, return true. Otherwise, we return false. It didn't disable. Let's try some tests. Try some tests. Come on, it's compiling. Uh-oh. All right, enable landing gear works, passed now. Enable landing gear does not work, did not pass. And disable landing gear works, did not pass. See if maybe we did something wrong here. Where'd our definition go? Come back. Come back. So we're disabling. If we're less than 1,000, don't disable. So if we're at 1,000 or more, we can disable. Let's see. So we said testing works. So if we go up to 2,000, and then we disable, we should get back true. It should disable, and then the status should be off. So what was failing with this one? 73. So actual landing gear, actual disable landing gear didn't work. So disable landing gear. If we're at or above 1,000, we disable it and we return true. That one feels like it should work. Let's try it again, just in case. Just in case. Enable landing gear does not work. All right, let's take a look at the test results. Nope, still failing. Okay, so we got 2 that failed. So enabling at 1,000 does not work. Oh, you know why these don't work, folks? Change altitude doesn't work. Yeah, because we're depending on another method for us to be able to actually change our altitude. We're not changing the altitude. All right, so it should work, but we need to fix change altitude first. Okay, how about that? All right, so 2 things here. So again, lots of different ways of approaching this. I like doing it this way, but there's lots of different ways to go about it here. I'm going to say if change in feet is, change in feet is greater than 0. Right, so if we're going up, that's the going up case. Right, going up. Then I'm going to check. Okay, let's just take our altitude. Current altitude plus equals the change in feet. Done. That's it. Then I'm going to check if my current altitude is greater than the max altitude in feet. I need to reset. So current has to equal the max. And I'll return false. That was no good. You did a bad thing. Right? You went too high. If I didn't return false, then we can return true. You went up and it was perfectly fine. No big deal. That makes sense right there? So if we're going up, go up. If we went over max, reset to max. Tell them no. Otherwise, yes, we got return false or return true. We were good. You went up successfully. Else, this is the going down code. Now, going down had to check a couple things, right? If we're going down, we need to see, are we going below 1,000, right? And if our landing gear is disabled, we can't do that, right? So we can check. So if my landing gear enabled is false, or I could say if not landing gear enabled, right? That's the same as not true would be false, or if it is false, it would be true. The knots and booleans get a little bit confusing, but hopefully that makes sense. So we're saying if it's disabled, right, and my current altitude in feet plus the change in feet is less than 1,000. Because remember, we're adding a negative number, which is subtracting. Yeah, you could have used void. I didn't require the boolean. I want to use this as the example, but I didn't want to make you guys have to deal with it. Right, so you could just do it or not, and that was perfectly fine. Okay, so if we're going to go below 1,000, our landing gear is not enabled, we need to stop at 1,000. Current altitude stops at 1,000. Right, and now actually I'm feeling bad about myself. I told you before, if you have a number in here more than one time, you should feel bad about yourself because it doesn't have a nice name here. So what I'm going to do is I'm going to refactor. I think I can do that. Extract, introduce constant. I think that's what I want. This is, I don't know, what do we want to call this one here? This is our, threshold for moving above below without landing gear. I don't know, that sounds terrible. So feet at which landing gear must be on. Sure, why not? And let's replace all occurrences. Look at that. And I'm just going to move it up top here because I think you should probably have that up at the top. And we could make it public or not private if we wanted, right? If we want to give other people access so that they know what that value is. Again, I'm not too concerned one way or the other which way we go about that. Okay, but now we're checking, hey, if we're less than or equal to the feet at which landing gear must be on, or greater than or equal to the feet at which the landing gear must be on, right? We got some nice words here. So if our landing gear is not enabled, if that's false, right, because not false will become true, then we get one true, and we're going less than that with our change. We're going to stop here at that feet at which landing gear must be on. And then we're going to return false. That was no good, folks. If that's not true, we're just going to add our change in feet. Right? And actually, you know, this piece here can actually happen. No, because we want to check after. That's okay. So we'll copy paste. I'm going to feel a little bit bad, but that's okay. We'll return true. Okay, again, we're adding because it's a negative number. So that's the not. Remember, not. So it's the inverse. Because landing gear enabled is a Boolean, true or false. We're saying not true or not false. You could also say equals false, right? That's the same here. Right, whichever way you prefer, or not landing gear enabled. So this is typically more concise. You'll find this more often, but there's nothing wrong with being a little bit more verbose about it. Like, hey, if our landing gear is false, not enabled, right? Okay, let's run our tests. Hopefully they all light up green. Let's take a peek. It's building. I got my fingers crossed. They all passed. Look at that. So now I feel good. I feel relatively confident that it did what it was supposed to do because we had all the testing for all the different cases. Right? Going down returns true, going down returns false, and we get stuck at that max, right? The feet which landing gear must be on. Right? Here we have all that. Stops at 1,000. Yeah, sure. But we could use that static value here if we wanted, but that's fine. I don't think we made it public. I think we left it private. Yeah, we left it private, so not private or private here. I'm doing bad with that word ban. I'm sorry. How do you guys feel? Does this make some sense, what we did for project 1? Wrote the test, wrote the class, and wrote the tests. And you didn't have to do the test-driven development. I just wanted to show you that. It's a good habit to get into. It helps you focus because you really need to understand what your code's doing to write the unit tests. And if you don't understand what it's supposed to do, you're not going to have any luck actually writing the class here. All right, let me do a quick little poll here. I'm going to say, so project 1, or how do you feel you did? How project 1. Good. Okay. Not bad. Just give me a quick good, okay, or bad there in Twitch chat. You should see that poll up at the top. It was good, was it bad, or was it okay? Yep, and I'll push all my code out to GitHub for you. Don't you worry. I got you. Give me a second. Gotta let that load. So take the poll while I push the code out here. So we are 2151 winter. There we go. So project 1 solution. Commit and push. Yeah, it's inversion. Right, so take that poll, let me know how project 1 was, good, bad, or okay, and we can go from there. Doing pretty well. All right. What are the results here? Is that like loads on another tab for me? I thought I could see it like at the top of chat. I don't know. Okay, so 7 people said okay, 4 people said good, no one said bad. That's good. That's good that it wasn't bad. And okay. Sure. I appreciate that. All right. It's 11 now, so why don't we take a break? We'll stretch, get some more coffee, and we'll come back and we're going to pick it up with the next chapter. We're moving into text processing and more about wrapper classes. I believe that's chapter, is it 9? I don't remember. I have to look at the number here again. Come on. That's low, D2L. Let's see. I think it's 9. And don't forget the Chapter 8 quiz is live now. I did remember to do that one. So it should be available for you guys to take by Friday, I think. Chapter 9, look at that. Yes. Chapter 9 we'll be coming back to, okay? All right, so why don't we take 10? We'll put on some more music here. Actually, my buddy joined this band here. Nope, that's not the right one. That's Elon Musk. I can't play that one. Into the Void. He joined this band. So they're like, hey, that's cool. Can I play your music? And they said, sure. So it's not DMCA restricted or anything like that. So you can play some of their music. If you like this alternative metal or whatever they called it. I think it's alternative metal is what they call it themselves. I haven't actually listened to all of it yet, but give it a shot. All right, see you guys in about 10 minutes. All right, we'll come back about 11:10. All right, gang. We got another minute here. But if I start another song, we're not going to finish it. So I thought I'd come back. Alrighty. So we're going to pick it up with chapter 9 in just a minute here. Let's see. It's like zoomed funny. There, that's a little better. Easier to read. A lot of cool stuff we can do with strings, this text processing, which is good. Good to touch on these. And then this wrapper classes idea is pretty handy. So we'll get to that. Hope you got your coffee. And we'll get going in just a second. All right. Okay. Oh, dad joke. You guys got it. You got it. I got a couple here. I keep finding good ones. So let me see. I save them all for you guys, of course. I know how much you guys appreciate good dad jokes. Where'd it go? I need like a different folder to save all these in here. Let's see. Man, was it that long ago? It was. Yeah, so the U.S. Mint is actually really cool. You guys know, well, you used to be able to. I don't know if you can, probably can't anymore, but soon we'll be able to go back and take more tours of the U.S. Mint, and where they actually make all of our money. Right, so they've got the place where all the bills get printed off and cut and all that slice stuff, and that's actually really interesting. Apparently there's like one small company that does the weird like fabric bill kind of thing. I don't know. They have to get vetted for as a supplier, but the coin part is really cool, where they do all the coin processing and stamping. But when we were there, I was showing my kids because history stuff is cool, and the coin machine, the one that makes all the coins, they got one for pennies, one for nickel or whatever. They broke down, and the guy who was giving us the tour says, I don't know why this is happening. It just doesn't make sense. All right, so let's pick it up with chapter 9. We start up a new project here. Predictable, yeah. All right, that's fair. Fair. All right, so chapter 9 is all about strings and string processing, and then it does a little bit about wrapper classes. I'm going to use a scanner keyboard, call it a new scanner, get the system in. And keyboard is our name for it. It could be ASDF. Does not matter at all, right? We just use keyboard because that's what Mr. Gaddis does. That way it's a little bit more consistent with what you see in the book. Import java.util.scan, so we can get some input from users, okay? When we ask people for things, for numbers and values, right, anytime we typically only get back strings. Keyboard has all sorts of next functions, like next int or next double. I'll try and recommend people don't use them, right? If you remember back to 1500, you probably had a project where you had to get some input that was strings and integers and things. And if you use these functions and then you try and get a string, bad stuff happens. And I'll show you that bad stuff here. So let's say here's an int for number equals keyboard.nextInt. So we'll say enter a number, and then, I don't know, how about, let's say, enter your name. Your name, and then we'll have a string for name, keyboard.nextLine. Okay, and then we'll print out did we do string formatting, where you could format a string with these little substitutors? Does that ring any bells? Or %d or something? I think it was this. It's the printf uses % signs, but string.format uses these curly brace substitutions. Favorite number is right? And you would call dot format. And we'd give it a couple things. Format? Formatted? Oh, I've got it backwards here. I'm sorry. So it's, here we go. String.format. There's the string. And here's the args. Okay. So, and we'll tell it name and number. Number. There. So, string formatting, right? Similar to the printf. We could also do, but there's no quick command for it. So, and for some reason they have different syntax, which drives me nuts. So this one would be %s for a string, and this is like %d for digits or something silly like that. So that should give us the same results. So you could printf, but with printfs you also need to remember your new lines versus string format, right? But anyway, let's try it. Let's run it. See what we get. So enter a number. How about 42? Enter your name. Uh-oh. Nope, that didn't. I did the wrong thing. Okay, that's not curly braces. Is it percent signs? %s, %d? I will just have to go Google that. Anyway, let's see if I can enter my name again here. So 42, no name. Remember what happens when you do a next int, next double, anything other than next, essentially next line. The enter key is a character, and it stays here. So I type 42 and then I hit enter. The enter stays because next int doesn't read the enter key. It reads the integer values. So then when I call next line, it gets that new line character and says, oh, you entered new line. Empty, you're blank. Right? Because next line will read until it finds a new line character. And it was sitting there ready to go. So if you use next int, you always have to call another next line after. And if you're going to have to call a next line anyway, just do it the first time. Right? So then we'd have to say keyboard.nextLine here. Then I should be able to actually enter my name. So this will take off, this takes out the, it's the enter key. Pressed after giving a number. So now I can give it a number. Now I can enter my name here. And now we get Eric, your favorite number. Right? Does this ring any bells? So the easier way to do this then, right? So that's the slow way. Right, I'll just put that in a little comment block. I prefer, oh, I guess we still need this enter a number. Here we go. We have to do all that. Next line, and use integer.parseInt. Integer.parseInt. Parse int. Was it just parse? ParseInt. Yeah, this is parseInt. And parseInt, you hand it a string, and it will turn that string into an integer. Right? This way. Because that way we're getting the next new line character off anyway. With next line. Does that ring any bells? Doing parsing of integers in Scanner? I don't actually know what you guys did in 1500, unless you had my class, and I told everyone to do it this way. But that's just me. Is it so far? Okay, cool. Cool. So we're happy there. Another hat. Oh, where's my other hat? All right, I'll change hats for you. You got it. I forgot to bring my nice chest bra hat. It's in my room right now, so I'll wear this one as punishment. There we go. I should come up with some more interesting channel points. Those are like the default ones. That Twitch is like, hey, here, have some channel points. Do some things. I don't know. Love that hat. Yeah, if you can come up with interesting channel point rewards, I'd be happy to entertain your ideas. Because, right, you got to have some fun here with this remote learning. Otherwise, it's just terrible. That is a good, it's a good hat for when I'm out in the summer. Especially as I'm getting bald, I start to really burn on the top of my head here. So I've taken to wearing hats. I usually do the baseball hats, but those get really hot. So like a nice little sun hat like this, I think I could really pull off. Okay. Tell a riddle. Ooh, that's a good one. Riddles are good. I'd need to come up with a lot more riddles. So this is called a wrapper class. So int is the primitive type. Remember Java, we have a couple primitive types. We have int and char and double and float and a couple shorts and bytes and a couple other things like that. Those are primitives, right? That they're the actual value there. The class here, then, wraps around that primitive type. So you could do silly things with classes and the wrappers here. So if you wanted, we could have an integer. Did I spell it wrong? No, I spelled it right. Integer. I don't know. 10 equals 10. I can say, hey, I want an instance of integer. I'm going to call it 10. Behind the scenes, it's doing this for it. It's saying new integer 10. But it's just so common, right? It's unnecessary. It even shows us in NetBeans, like, you don't have to do this. Because why make people type this if we know that's going to happen? So the Java compiler does all this stuff for us automatically. Or I could say, hey, I want a int 5 to equal new integer of 5. Right? So we can take primitive types and assign them their wrapper class. So this is either, it's called boxing or unboxing. Use the opposite hand mouse. I don't actually think I could left hand mouse. I can use the trackpad with my left hand, but not the mouse itself. And then I'd be all crossed over and be like this all the time. 100,000 points to shape my head. See, I wouldn't be able to do that on stream. Like, it's got to be something quick and silly. So you can unbox when I go from a primitive and assigning the wrapper type that will unbox it. So that's what we're doing over here. We're taking an integer, the wrapper class version, and we're unboxing it to store in the primitive integer type. Or you can box. We can take a primitive type and assign it the wrapper class version, and Java will go between the two for us, which is really nice. So this is unnecessary boxing here, right? Not needed. We don't need to tell it specifically that it is the type of integer wrapper class. It does all that stuff for us behind the scenes, which is really nice. So that's the wrapper class. But they let you do lots of cool things, right? Integer has some cool functions, right? You can turn it to a hex string, a binary string, an octal string, if you wanted. Remember we did all that binary counting a while ago? And like it was zeros and ones, and you said, okay, let's see how we do that here. So let's do that. Let's say for I don't know, or while. I don't know, int value is 0, and we'll do it in a for loop. All right, sorry, for int value is 0. No, goodness, value is 0. Value is less than, let's go 256. Value plus plus. Let's print my integer dot to binary string value. Let's see if we can get out our binary strings here, just for fun. See what they look like. Here we go. Look at that. We get binary. 0, 1, 2, 3, 4, 5. So maybe we should print that out too, right? So we'll say value plus and a colon, maybe. How about that? Will that be a little cleaner here so you can see their versions? Yeah, the wrapper class is just, it wraps around the primitive type. So all the primitive types in Java have a wrapper class that gives you additional functions. Oops, that asks for a number, not my name. I'm not paying attention. Number and then a name. There we go. Here, and here's our binary. Right? So 42 in binary. 101010. Look how beautiful that is. It is the best number. All right, did you guys chat about binary back in 1500 briefly? It's not all that important, but it's interesting. You could do it in hex too if we wanted. No. No, Java does not compile into binary. Java compiles into Java bytecode, which is the .class file. And then the Java virtual machine runs the compiled class file on whatever operating system it's running on. And we can go take a peek at some of those file. I can't, why is there no open here? This is terrible. I just want to like open. Find? No, it's not find. I just want to like open the folder, but that's okay. You go find the folder here. Yeah. It's called bytecode. It's not actually things. I don't know. It's I'll show you here. Let me find my GitHub folder and not show you all of my other things. 51, here we go. Boop. So chapter 9, why not? Because we're looking at chapter 9. So in the build directory, we get the actual class files generated here. So chapter 9.class, that's the compiled class file here. And you can open this up with a text editor. Excuse me. I know, I've done some dumb things before. Roazoro, I don't know. All right, here we go. And code says, oh, hey, it's not a regular text file. Yeah, we won't open it anyway. And you'll see there is some text, right? Some of this stuff just comes out as text, and we do get to see what it is, which is interesting. Other stuff, I don't know, who knows? Like we see, hey, here's a string here. Right, so that's the class file. So the Java virtual machine can read this and execute Java commands. If you can't read this, go back to 1500. I mean, go take a compiler class at a school for computer science if you want to work on compiler stuff. This is nonsensical. Okay. So the wrapper classes are cool. They give us extra functionality. Right, that's sort of the idea with the wrapper classes. Not too much more about those. Let me double check I'm not missing anything. Yeah, boxing and unboxing. Ooh, min and max are fun too. So like integer, there's a min value and max value, right? 2 to the 31 minus 1, negative 2 to the 31 for min and max, right? The size of an integer, oh, look at that, it's 32. Number of bits used to represent an int value in 2's complement binary form. Yeah, that's all. You know, you can go take that interesting class and learn about that, whatever all that nonsense means. It's actually really interesting. It is. It's just lower level stuff, right? And this type here is that type of integer. That's the wrapper class, right? Cool. Bytes. 4 bytes, 32 bits, min and max value. Get integer from a string. Look at that. Lowest ones bit, highest ones bit. So you can do a lot of cool math related operations with this that are kind of fast. You can get the sum of 2 numbers instead of adding. I don't know why you'd want to do that, but you could. Yeah, you can do some cool stuff. Usually we use the parse. And that's pretty handy here. You can reverse an integer. Reverse its order of bits. Huh. Sounds fun. Or you can reverse the bytes. Rotate left and I don't even know what those mean. Sure. Yeah. But lots of cool stuff built in. Yeah, why not? All right, so this is more the wrapper classes. I want to save the string stuff for Thursday. And I want to talk a little bit more about the project. So I got some questions, which are good. Questions are definitely good here about the project, project 2. And I want to make sure you're not shooting yourself in the foot, making this harder than it has to be. I promise, it sounds like a lot, but it's not as big as you might think it is, okay? Maybe not quite as big as you think it is. So we'll spend a little bit of time talking about it again. I'm trying to give you some pointers. And remember, it is due 2/18, so it's coming up. We got 9 more days on this one, right? 2/18, 6 p.m. Definitely get started, right? If you haven't yet, now that Project 1's done, hopefully you had that in by Thursday anyway, but you got to get started on this and get working early. Thursday happens to be my busiest day of the week, so maybe these due dates are unfortunate, but it's really difficult for me to get back to you and talk to you on Thursday because I have morning class, afternoon class, late afternoon class, and evening class. Right? So if you want to ask me questions, you got to get in early. And this coming weekend, I have more projects I need to get done. I got some IKEA furniture I have to assemble, and that's always quite the adventure. It's easy enough. It's just rather tedious. So we have to do some IKEA furniture, move some stuff around the house. So I won't be available much of the weekend at all. So you've got to get working on it this week. Come to office hours today on Wednesday. I've got just a little bit of time for office hours on Thursday. Usually that's for the night class folks. But if you want to drop in between 5:30 and 6, you can. And then next week, Monday office hours, Tuesday office hours, Wednesday office hours are your best bets to catch me. And don't forget, we have study group Tuesday, Wednesday, and Thursday. I cannot recommend you guys go to that enough. It's super helpful for you guys to get together and chat about these topics. Again, you are welcome to discuss the project, right, with your classmates. I expect you guys to talk. You've gone too far if you have to be taking notes. Right? Does that make sense? So if you're taking notes of like specifically this is what I'm going to do, we've gotten too detailed, and that's getting into the realm of copying off of someone else. But if you want to talk about, yeah, hey, I'll have a class and it'll do this, I'll have some methods, or this is how I want to do, I think I can find, this is how I have a full house. I think you would check for this and you check for that. That's all cool, right? I'm good with that. I understand. Yeah, it's in all that Zoom info should be in D2L. There's a document with a link, and then it's in the calendar events as well. I don't know if anyone actually uses the calendar, but I saw it there and I thought it might be fun to put it in. And do remind me, break is coming up, and I haven't taken stuff out of the calendar for break. So I'll have to do that as we get a little closer to our winter break. So, okay. Anyway, so our poker game, where it's not even 5-card draw, it's just 5-card done. I think they call that stud. I forget, 5-card stud maybe, because it's not a draw. So we're going to have a deck, which is just a list of cards. We're going to have enums in the card class for face and suit. No, it's not Hold'em. No. Hold'em is later. We can do some fun stuff with that. So for card, we're going to have that copy constructor, so you can make a new card instance from another one in case we want to make instances and not pass them around. This one's a little bit silly to have because cards should be read-only. They should be enumerable. You got to email me, software. Send me an email about it. So the copy constructor is useful more for mutable types. Yeah, and enums essentially that. They're just a little bit easier to use. And then you can also get ordinals out of enums, which is fun. Right, so if we have an enum, I don't know, moods, why not? And we'll say happy, sad, grumpy, and tired. Why not? I'm missing something here. Equals. Put it somewhere wrong. Up here? No. I just, okay, fine. It's not worth memorizing this stuff, right? Don't bother memorizing it. Just look it up. I'll look at our previous example. Might as well. Enum. Oh, no equal sign. Okay. That's what it is. Okay, so now I've got moods as an enum type. Right, and then we can do cool stuff like mood dot, and I get moods dot. And I have all those options here. Remember, they're assigned values. They're actually integers behind the scenes because integers store very nicely in only 4 bytes. So the first one is usually 0, and then 1, and 2, and 3. So you can use that order to your advantage if you want. So I can say enum.grumpy, and then I can get some values out of it here. Right? If I want it, I could get its ordinal value back out. You can loop through enums, right? I could say for what do I call that one? Enum mood in moods. There we go. Nope. Moods. Moods. Values. Mood. What is mood? Okay. I think we should be able to get the values out. Let's see. Let's just see if we can print some. Mood. Oh, you gotta hit tab there. Mood. See if we can run that. See what we get. There we go. Yeah, we get the values here. Mood colon, yeah. So remember, var is that like the special way of saying I'm not going to tell you what type it is here. I think we would say moods. Mood is the right, yeah. So it's a type of moods here. Sure, but you can get the values out, right? So if we have a bunch of moods, we can do that, and we can loop through. We can do something with them. Right? I've got the individual value as I'm looping through all of the values here. Which is cool. I could also print, then that's the mood plus colon, I don't know. We'll do its mood.ordinal. Let's see what its value is there. Is that a function call? Might be a function call. Yes, mood, coffee. So you can see the ordinal values here, right? The first one's 0, and then 1, and then 2, and then 3. So you can use those to your advantage. Something that might be interesting for you, right? You could say, let's do moods.grumpy is greater than moods.sad. So let's see which one is the greater mood, right? I have to force that in there, maybe. Moods.ordinal, sure, why not? Ordinal.ordinal. Now it's getting too long. Ordinal function call. Look, I can compare moods and see which one's greater. So true, grumpy is greater than sad. Right? Its ordinal value is greater. So you can compare sort of things like that just by position, which is kind of fun. That's especially useful if you're doing like the face values of cards. You could just use their face ordinal for comparing. It works out relatively well. Let's see. So yeah, looping through is helpful, and you can loop through. You can do multiple loops, right? If you have more than one enum for putting together a deck of cards, perhaps. Let's see what else. What else? You're getting a random card, right? Just make a pick one, a random index. You can use random for that. This high to low or low to high actually doesn't matter. Just keep them sorted. Next Thursday, 2/18, 6 p.m. You want to do, Snake? You got 9 days. Okay. Worry about the game part after. Right. What you want to do is you want to get card, you want to get deck, you want to get poker hand. You want to get these ones working. Right. Accept the 5 cards, sort them. There's some helpful ways to do some sorting here. So if I have a list of values here, this is like int array list of type integer values equals new array list of, oh, I think I can just stick the numbers in here, right? 3, 7, 9, 1, 12. Sure. Right, I can just give it some random values. I can take values and Import array list first. Yep. Import. Did I import? Did. Oh, new array list integer. Can we do it this way? Array list initializer. Let's Google it. Or Bing, right? Bing gives me free coffee. I don't know why it's so slow. How? Come on, give me like, I don't know any of these sites. Java to blog, Stack Overflow. Usually they're a better hit than some of those other sites. I'm gonna guess you can't do it, right? Arrays as list. Oh yeah, so you can't. Shoot. Okay, sure. I give up. Int array values. Okay, here's just a regular array. Values. There's not a lot you can do with just values, right? Not a lot here. But there's this arrays. Nope. Arrays class. Nope. Arrays. Dot. And arrays. Java.util.arrays can do some cool stuff. Arrays can sort values. So let's see, can we print out values? I don't think it's going to print nice for us, is it? Let's see. Let's see if we get lucky. I don't think it'll print anything nice. Yep. Garbage. That's all right. So for int value in values, print value plus a space. That loop is done. Print a new line. Link to VOD in Discord? Like the YouTube exports or the Twitch VODs? I've been adding the... Yeah, I've been adding them to the Desire to Learn. There's this in content. There's the lecture archive. Where'd it go? So if you're looking for them, they're all listed out here in content. They should all be there if I did it right. But I can post them to Discord as well for fun. You want the Twitch VODs then? Those ones are usually available faster. So the lecture archive section has them here. Cool. So look at this. My array got sorted. Right? It's kind of cool. Oh yeah, I'm sorry. Yeah, they're all in D2L. I linked to the YouTube ones in D2L because they'll last longer. The Twitch VODs come down after about 45 days. So if I were to put the links to them, they would disappear. So that's why I export over to YouTube to keep them around for the semester. Or longer, perhaps. I don't know how long I'm going to keep them. Still TBD. Okay, so we were able to sort there. Sure, we can remove that one. Why not? Okay, that's pretty cool. Right, so this sort is pretty handy. And this is in ascending order. It's low to high, which is okay. It doesn't have to be high to low. So way to use digits as the constants in enum. Maybe use text like 1. Yeah, you have to. It's got to be strings or text here. It can't be numbers. So you'd have like 2, 3, 4, 5. Yep. It's not too ugly. Don't worry. Don't worry. Okay, so if we had that, but now if we were to add a class here, new class, let's just call this card. Why not? We'll call this one card. And say card here was just, it's okay. It's not what we're supposed to do, but we'll just call it face. We'll put card, card for face. This dot face equals the face. And a get face. Insert code getter. Get face. I'm going to put that down here. Now, if we had an array of cards, per se, where do we want to put this? Put it up here. Why not? If we had a card array called cards equals a new card array. Oh, here, we'll just throw them in here, right? So we can have card, new card of 2, and a new card of, say, 3, and one more. A new card of, here, let's change that order. Let's go like 4, 3, and 2. There's 7. I don't know, 4, 7, and 2. Why not? Make a card array. Can you use numbers when selecting for an enum? Like 2 should print out. You can convert somehow. I'm trying to remember. You can get moods. I think you just convert. So you can say like an int value or some number equals 3, and then we could print as moods of some number. I think you can cast it. Maybe not. Nope, doesn't let you cast. Value of? No, I don't think it lets you do that. There's some, I feel like there's some way to do it. Like, we can take a look and see. But anyway, if I have this list of cards, right, if I take arrays.sort and I try and sort cards, think I'm going to get sorted cards? Oh no! Exception. Comparable. Sort. Arrays sort. Oh no! It broke. Card cannot be cast to java.lang.comparable. Comparable module. You can only sort things that are comparable, right? If you tell Java how to compare them. Well, turns out, come over here to card, and you go to insert code. You have a, I thought it was there. It's not there. Bummer. That's okay. Java comparable. You might not know what an interface is, and that's okay. We'll get there when we get back to some more advanced stuff. But this is comparable. It's an interface. So comparable will let you compare things using a compare to method. Okay, comparable is kind of cool. We can compare things. Hydration, thank you. Thanks, more coffee. So if we will implement comparable, let's comparable card. You know, this looks like nonsense, but if we add this here, we're telling Java, hey, I can compare myself to another card. And then it says, oh, it doesn't implement it. And hopefully you talked about some of this stuff. You might not have, and that's okay. If it doesn't make any sense, don't sweat it. I just want to show you this one here. So it's saying, hey, we're going to show you how to compare to card. We can do that. Right? So compare to is tricky. What it's supposed to do, right, is give you which one is bigger. Right? We've been able to compare integers. So a negative number, this is like its natural ordering here. Array sort uses that, so you need it here. But what compare to should do is give you a negative number if it is less than 0. It should give you equals if it equals a 0, and it should give you a greater if x is greater. So what we can do is we can return face minus o dot face. So take my face value, subtract their face value. If I am greater, it's going to be positive. If I'm less than, it's going to be negative. Okay, so this returns negative if less than, 0 if equal, and positive if greater. Okay? So once we have this here, once we implement comparable, now I can sort without it crashing. Okay? This might be helpful to keep stuff sorted. If you want to do your own sort, you can too, but this is one way to go about it. Now again, you're not using just a straight integer value, but I think you know how to get integer values out of enums if you want to use faces as enums. Okay? So you got some options here. You guys are welcome to implement this comparable to make sorting easier in your poker hands with a list of cards. Okay, so only works if you implement comparable, and have the compare to method. All right, hopefully that's a nice little tip that'll help you guys out for the project. We are out of time. It's been fun. I will catch you on Thursday. Don't forget study group today at 4, Wednesday at 6, Thursday at 4. If you do go, we are taking attendance, and you can get a bonus point on the quiz for that week's content. I might not even add it right to the quiz. I might, because it's easier for me. I might just at the end of the semester have like this is all your bonus points, and that's probably easier. So we'll see how that goes. But you can get bonus points for going. You guys take care. I will see you around.